Good morning, children. We'll continue with the reflection of light, A part, which I did in the Zoom class. Few more things you have to see. Let's see that. Okay. The first thing is formation of image of a point object by a plane mirror. Okay, formation of image of a point object by a plane mirror. So this is a plane mirror, object is here and the image of it is formed here. Now, how do we draw a ray diagram to get this image? Okay, so that is what we are going to see. Now, so let's take this as a mirror and this is the object. Okay, it's just a point. Object is just a point in front of the mirror. Now, so image will be formed here. Now, if you have to show it in a ray diagram, what you have to do, so usually what we do, we draw an incident ray, and this being the normal, and the ray will get reflected and go like this. Okay, this is your normal. The ray will get reflected and go like this, and these two angles will be equal. Yeah, so this is what happens. Now, if I have to show the image formation, I need to take at least two rays. If you remember, in concave, convex, in every ray diagram, we used to take at least two incident rays. Okay, so let's take another incident ray from the object. Okay, so from this object, I've taken another incident ray, incident at some other angle. So for this ray also, the reflected ray I can draw. Okay, when you draw the reflected ray, make sure this and this angle are nearly equal, at least roughly they are equal. So your reflected ray will go like this. So you will get two reflected rays going like this. They will be diverging, means they're not going to meet here. So what you have to do, you have to extend it backward. So with your scale, you put dotted line, extend it backward. Same way, this ray, and both will meet at a point somewhere here, and that's where the image is said to be formed. Okay, so O is the object and I is the image. Now this is how the ray diagram goes. Any two incident ray at different incident angles, then they form corresponding reflected rays, and if they extend it, the lines will meet at a point. That's where the image is formed. Okay, so now actually, ideally, you should use a D, okay, to mark these angles. Suppose if this angle was 30, you should mark this also as 30. If this is 15, this also should be 15, and then you should draw. But then we don't use D to draw all that, but there are some things you have to remember. Now, one characteristic of image formed by plane mirror is the distance between object and mirror should be the same as distance between image and the mirror, means perpendicular distance. Okay, so you draw this distance. Okay, suppose this comes out to be 3 centimeter. The image should also be at a distance 3 centimeter, but it is not at 3 centimeter, it's somewhere else. That means this ray diagram is wrong. Okay, so that is what will happen if we don't use a D, but using a D will also take a long time. So I'm going to teach you one way by which you can, without using a D, still you can get a proper diagram. Okay, so I'm using rule lines for that as you use your ruled notebook. So this is my mirror, and then I have taken my object somewhere here. So two incident rays, one here, any angle, another one here, normal. Okay, so this angle should be 90 degree. As soon as you draw the incident ray, at that point you have to draw a normal. Again, this should be 90 degree. Okay, you're not going to use a D, but okay, if a mirror is like this, 90 degree line, normal will be like this. So this you can have to do it approximately. Now then this reflected ray will be here. Now, before drawing the reflected ray, what you do, you know that this distance, so with your scale, okay, with your scale, you know that 1 2 3 4, on the fourth line I've taken my object, so 1 2 3 4, my image should be somewhere here. I should get my image somewhere here. So you fix the position of image first. So with the scale, use a scale so that it's in a straight line. Okay, use a scale so that it should be in a straight line. And if it is at 4 lines above, then this will be 4 lines below. Now, after marking the image, so what you can do is take a scale, put a dotted line till this, and then a solid line. Same way, put a dotted line till this, and then a solid line. So this way you get an exact image, the correct ray diagram without using a D, and in short time. If you start using D, it will take a long time. You're not going to have so much time. So this is one way to draw it without using a D, but still to get a right diagram. Once again, I'll repeat. You mark the object here, okay, maybe at fourth line. So draw 2 incident rays at least from that at 2 different points, and at those points you draw a normal. This should be 90 degree. Okay, to your mirror it should be like this. That's called normal 90 degree line. Now, actually what you should do, you should draw the reflected ray, then extend it backward and meet at I. But it can meet anywhere. Okay, that's what happened in my previous diagram. It is was meeting somewhere else, and that diagram is not correct. Okay, so what you do, you're going to go in the reverse way. So if the object is here, you know that the image also should be formed at the fourth line and in a straight line. So with a scale, keep a scale and mark a point here on the same straight line. So once you have decided the position of image, this should be the position of image. So what you do, take a scale, put a dotted line till this and extend it. Same way, this and this point you join, put a dotted line and then extend it. So these two are incident rays, these two are reflected rays, and when they are extended, they meet at I. I hope you have understood this. You can pause the video and please draw this diagram in your notebook. Image formed by a point object. Okay, formation of image of a point object by a plane mirror. We will be using this in B part, so I had to teach this. Okay, now same way, extended image. Extended image means this was just a point. Now if I have an object like this, I will have to get an image like this, because lateral inversion, right? The left side of this will become the right side of that, and the right side of object will become left side of the image. So object is like this and my image is like this. So how do we get that? Same way, from B, you just consider this as a point source and this as a point source and follow the same procedure. So incident ray, so you mark the image first, then connect this dotted line, extended line, that's your reflected ray. Same way from A, draw 2 incident rays, mark the image. So you keep your scale, okay, keep your scale and on the straight, okay, at a straight line at whatever distance this is from here, at the same distance mark as A dash, then you get the image. Okay, so this is how for extended object you can get a image. Okay, but anyway, I want you to draw only this in your notebook because you'll be using this later on in B part. So please try to draw this in your notebook. Now, before going into the B part, one more that lateral inversion concept. There are a few practical applications. I would want you to understand it. Now, we'll try to form the mirror image of all the alphabets. Okay, suppose A is there. If I write this and keep this in front of the mirror, how will it look? It will look like this. Okay, you won't have any difference. Why? Because it's a symmetrical Okay, it is symmetrical. Left right symmetry is there. Means if I divide it, if I draw a line here, it divides it into two equal parts. So, but if you take B, the image will appear to be like this. C, image will be like this. D, image will be like this. These are all not symmetrical objects. That's why you get a different, the image object looks different, image looks different. Okay, E, so like this you can keep drawing for you can keep writing for all the alphabets, children. You just do it, it will be really interesting. Then what you do, you try to write your name. Okay, so words, basically this is just letters. What will happen, how will it look if I write a word? Suppose if I'm writing my name and keeping it in front of the mirror, the image will be, so in the image, this will be the first letter, this will be the second, this will be third, this will be fourth, and this will be the last. Okay, so the image of N will be like this. Sorry, okay, N, this distance and this distance should have been same. I'm sorry, it should, okay. And then A will be the same, S will be like this, U again is symmetrical, and S will be again like this. Okay, so if I write Susan in a paper and keep it in front of the mirror, I will see this as the image. Or if I write this in a paper and keep it in front of the mirror, then I'll see Susan as the image. Hope you understand. So it'll be fun. You write your own name and write a mirror image of that. Okay, write a mirror image of that. Now why we are doing this is, there is one important application of this. Now if you would have seen in front of ambulance, okay, in front of ambulance, so one is they have this signal of doctor or medical, something related to that. Also, the word ambulance will not be written as a straight line, its mirror image will be written. Now, how do you think ambulance ka mirror image will be? AMBULANCE. Iska mirror image will be ECNALUBMA. Okay, this is the mirror image of the word ambulance. So in an ambulance, you will see only this. You won't see this word. On an ambulance, only the mirror image will be written here. Okay, CNNALUBMA. Okay, so if you would have watched carefully, so usually you expect the heading to be straight, right? Ambulance means straight ambulance. But in an ambulance, it will be written, the mirror image of the word ambulance will be written. Why is it so? Now, one main reason is, now suppose your father is driving a car and going, and there is an ambulance coming behind. Okay, so through the rear mirror, through the mirror, side mirror, your father is looking at the ambulance. Okay, so when he sees, okay, in his mirror, the original image of this will be ambulance, right? So it will help him to read it quickly that it's an ambulance, and he will be able to give way so that the ambulance can go forward. You know, we are not supposed to we are supposed to give way for ambulance whenever we hear the sound of an ambulance, right? So purposely they have written the name in mirror image so that when anybody in front sees it through their mirror, they'll see this word, and that will help them to quickly decide, oh, there's an ambulance coming behind, so I have to give way for it, and you can just get aside from the main path. Okay, so this is a very important application in practical day-to-day life you have seen. Okay, now there is one more thing I want you to remember. There are some words, the mirror image and the real image will be same. Okay, see, if it is Susan and all, like, it's very hard for anybody to understand. If I just write it and find out what is it, it's hard for people to find out this is a mirror image of my name, right? But there are certain words whose mirror image will be the same as the object. For example, take words like mom. Okay, the mirror image of this will be, so this M will come first, O, M. So object is also mom, mirror image is also mom. Okay, so MUM also is like that. Tit, if I write tit, mirror image will also be tit. Tat, tat. Okay, so if you have the first and the last letter same, and if they are symmetrical, then see, in this case object and image will be both identical. This case also it is identical. Okay, so you can try and find some words like this whose mirror image will be the same as that of object. Okay, you can try this. It will be very interesting, right? So these are some of the general information. It will be very useful for you. Now we'll go to the B part. Okay, the B part, image formed in a pair of mirror. As I told you the other day, there are some cases where we see more than one mirror. The best example is in a barber shop. There will be two mirrors kept parallel. Now, how the images are formed, how many images are formed, and how they are formed. That's what we're going to see. Now, if you have seen in a barber shop or in a boutique, you'll see so many images, okay, in front and at the back. How is this possible? We're going to see that. Okay, so before that, there is a formula to calculate number of images. Okay, now the main the angle between the two mirrors, so more than one mirror has to be used to get many images, and the angle between the two mirrors is very important. I can keep the mirror like this, 90 degree, or I can keep it like this at an angle 60 degree. In each case, you will have different number of images. Okay, so if I take this angle as theta, okay, this angle between the two mirrors is theta, then the number of images formed is given by the formula 360 upon theta. Number of images formed can be found using a formula 360 by theta. Okay, now there are two cases. Okay, there are two cases, case 1 and case 2. Now case 1, if the answer you get is an odd number, if n is odd, if n is even, the answer you get if it is an odd number. For example, if I would have had 90 degree, what would my n be? 360 by 90, that will be 4. So it will be n is even. Okay, in some case, suppose if I take 45 also is 8, 60 degree is also even. Okay, if I take 72 degree, okay, 360 by 72 if I take, it is 5. So odd number, even. So both the possibilities are there. Now if n is odd, then again you have two cases. One is if object is kept symmetrical or asymmetrical. You understand what is symmetrical and asymmetrical? Symmetrical means the object is kept exactly in between these two. Means if it is a 90 degree mirror which has two mirrors kept at 90 degree, and if I draw an angle bisector here, and if the object is somewhere here, that's called symmetrical. Okay, it's at equal distance, perpendicular distance between this and this are equal. That's called symmetrical. Do you understand? But if I have the object anywhere else, here, 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 then it's called asymmetrical. You can have image anywhere, but this, if the images are here, then they are called asymmetrical. So if it is exactly on the bisector line, anywhere on the bisector line, then you call object is at symmetrical. Okay, so if it is symmetrical, okay, if it is object is kept symmetrical, then the image will be n minus 1. Image will be n minus 1. If it was kept asymmetrical, then image will be just n. Okay, you understand this now? When we do a numerical, you will understand. If n is even, whether it is symmetrical or non-symmetrical, always number of images will be n minus 1. N minus 1. Okay, mostly the number of images will be odd number. Okay, so that's why even if you get an even number as n, you have to always subtract 1 from it. So no problem. But if you get n as odd number, then again there are two possibilities. If the object was kept at symmetrical, then you have to, number of images will be n minus 1. If it is kept asymmetrical, then it will be n, only n. Okay, now you can take this example itself. No, this is even, right? So in this case, if suppose theta is 90 degree, n will be 360 upon 90. That will be 4. N is even. So what you have to do? Number of images will be 4 minus 1, 3 images. In this case, 3 images will be formed. Okay, in this case, you don't have to think about symmetrical, asymmetrical, because you got n as 4. But on the other hand, suppose if theta is 72 degree. So my n will be 360 by 72. This will be 5. Okay, 72 5s are 360. So my n is odd now. Now in the question, they would have mentioned the object is kept symmetrical or asymmetrical. If in the question they have given object was kept at symmetrically in between the two mirrors, then your number of images will be 5 minus 1, that is 4. So your answer will be 5 minus 1, that is 4. 4 images are formed. If in the question they have mentioned that object is kept asymmetrically between the two mirrors, then your answer will be number of images is equal to 5. That is if it is asymmetrical. Hope you have understood this, children. It might look little confusing, but take time, try to understand it, then it will be clear. Okay, I'll solve one numerical for you, then it might be much clearer. Next page, page 157, numerical number 1 is very easy, 90 degree and 60 degree. So 90 I have already done, you can try 60 by yourself. Now come to the second one. An object is placed asymmetrically, first case, second case symmetrically between two plane mirrors inclined at an angle of 50 degree. Find the number of images. So theta is given as 50 degree. First step, n is equal to 360 by theta. 360 by 50. You cut it and you will have 7.2. Let us round it off to the nearest one. So it will be 7. Okay, 0.2 is smaller than 4. So you cut it. So you have 7. N is equal to 7. So it is odd number. Then now they have given both the cases for asymmetrical also and symmetrical. So first case, if it was asymmetrical, number of images will be equal to n, that is 7. Second case, if it was symmetrical, number of images n, number of images is equal to 7 minus 1, that is 6. number of images will be 7. In asymmetrical it is 7 and in symmetrical it will be 6. Hope you understood, children. So this is how you have to find out about the number of images formed. Okay, so today you would have drawn this ray diagram. Okay, and then I want you to write your name's mirror image, and then I want you to solve these two numericals. That's a homework for today. Thank you, children.